Hi everybody, today we're going to talk about scientific notation. Notice the word that you see in the first part of this title, scientific. That means that we're going to see this a lot in science. So if you're ever in the science classroom, that might be a spot where you're going to be using scientific notation. Let's learn a little bit about it. Let's take a look at this chart. What I want you to do is I want you to fill this in and express your numbers that are written in scientific notation, which is the first column, and I want you to go ahead and transform them and write them in standard form. We're going to walk you through this step, and then you can do it on your own on the next few pages. Let's take a look at the first one. We're going to take what we learned about exponents and we're going to apply it to scientific notation. First things first, it says 4.16 times 10 to the third. Notice that we are multiplying those two factors. Now, what do we know about exponents? We know that 10 to the third is really 10 times 10 times 10. So we're going to go ahead and write that out. So we have 4.16 times 10 times 10 times 10. And if you take your calculator, you should know 10 times 10 times 10 is 1,000. So this is 4.16 times 1,000. If we're going to go ahead and write that in standard form, which means just writing it, oh my word, which means just writing it as a number, then this is what we're going to do. We're going to take our calculator and we're going to multiply 4.16 times 1,000. So you should be getting 4,160. Now let's take a look at the next one. The next one says 4.16 times 10 to the second. So let's go ahead and write that one out. Times 10 times 10. We all know that 10 times 10 is 100. So this is really 4.16 times 100. Notice, if you use your calculator, 4.16 times 100 is 416. So it matches. Let's look at the next one. The next one says 4.16 times 10 to the first. 10 to the first, we know, sorry, I'm outside and there's some bees. We know 10 to the first is actually 10. So 4.16 times 10 is 41.6 if you use your handy dandy calculator. Let's take a look at the next one. If we write this one out, we should all know 10 to the 0 is 1 because anything raised to the 0 power is 1. So if we take 4.16 times 1, anything times 1 is itself. So we get 4.16. Okay, here come those negative exponents again. Let's check this out. We have 4.16 times 10 to the negative first. How do we make that a positive exponent? Try to remember that in order to make this negative 1 a positive exponent, we have to put it under 1. So that's why we have written out here 4.16 times 1 over 10. Now if I make the 4.16 into a fraction and I multiply straight across, I get 4.16 divided by 10. If you take your calculator and you do 4.16 divided by 10, hopefully you get 0.416 as your answer. Notice that when I'm multiplying by a fraction, my number actually gets smaller and becomes a decimal. Let's take a look at the next one. The next one says 4.16 times 10 to the negative second. Once again, to make that a positive exponent, I'm going to go ahead and put it under 1. Then I'm going to go ahead and write it out. So I have 4.16 over 1 to make it a fraction because I'm going to multiply straight across times 1 over 100. This now becomes 4.16 divided by 100. Notice that when you take the 4.16 and divide it by 100, you should get 0.0416. Notice again, when you multiply a fraction, that number gets smaller. Sorry, I think I have bugs attacking me. Let's look at this in more depth. Look at these two examples below. First one we have is the 4.16 times 10 to the third. Now recall from the chart that 4.16 times 10 to the third is actually written as 4,160 in standard form. This is going to be a fun lesson to watch today. Sorry. Now if we look at the next one, notice that negative 3 now takes your 4.16 and makes it a smaller number, and it's actually a decimal, 0.00416. What do you think happens to the number in standard form when the exponent is positive? We kind of talked about it a little bit. It actually becomes bigger. So I'm going to go ahead and write becomes bigger. Right? Didn't it become bigger than the 4.16? Yeah. It became 1,000 times bigger. Now let's take a look at what happens when the exponent is a negative 3. When it's a -3, it actually became smaller. So I'm going to write becomes smaller. It actually becomes a decimal, and I'm going to go ahead and write this down. Less than 1. Now let's find out, is there a faster way to convert numbers from scientific notation to standard form? If you notice the decimal point in the 4.16, and then notice your decimal point in the 4,160, look what happened to it. Look at my exponent of 3. Does that have any relation to what happened to your decimal? If I take my decimal in the 4.16 and I move it 1, 2, 3 and put a 0 in, notice what it becomes. 4,160. So that exponent tells me how many places to move the decimal to the right. Now let's take a look at our negative. Notice it's a -3. Because it's a -3, I must move to the left 3. 1, 2, 3. And look what happens. My decimal matches my answer. So my exponent actually tells me which way to move the decimal point. So for my answer down below, I'm going to say move the decimal point the number of places, and you can go ahead and abbreviate, indicated by the exponent. Sorry, my handwriting's so messy. So I can go ahead and do that by the exponent. Let's take a look at some more examples. These are our rules, so I want to make sure that you have those solidified. We can use what we discovered as a shortcut to express numbers in standard form. Recall what we said: when we multiply factors by a positive power of 10, move the decimal to the right, the number of places indicated by the power on the 10. Let's look at our example of 5.34 times 10 to the 4th. If I'm going to go ahead and work this one out, and I'm going to use my shortcut method, that exponent of a positive 4 tells me to move my decimal point to the right 4 places. So 1, 2, 3, 4. I go ahead and fill in my zeros, and I rewrite my number. Remember to always rewrite your number. Never write your number with bubbles under it, because then it actually has 2 decimal points, and that's not really a number. Let's go ahead and look at the negative side. I know that when we multiply factors by a negative power of 10, we move the decimal to the left, the number of places indicated by the power on the 10. Now let's take a look at our 5.34 times 10 to the -4. Once again, I start writing with my decimal, my normal number, my factor. The -4 tells me to move my decimal point 4 places to the left. So 1, 2, 3, 4. There it is. Fill in my decimals, rewrite my number, and bam, there's my number in standard form. Awesome. Now I want you to practice. I want you to go ahead and convert these from scientific notation to standard form. I want you to go ahead and pause the video, give it a try, and then come back and check your work. Hopefully you tried those on your own by pausing the video. Now I'm going to go ahead and show you the answers. Remember, if something gets stuck or you don't understand something, you can always go back and look at the notes. So 9.1 times 10 to the 3rd, hopefully you got 9,100. 6.7 times 10 to the -2nd, hopefully you got 0.067. Remember, you're moving that decimal place 2 places to the left on that one because it's a negative. 2.758 times 10 to the 5th, I'm going to move my decimal to the right 5 places to get 275,800. 5.682 times 10 to the -1st, the -1 tells me I move my decimal to the left 1 place, so I get 0.5682. And finally, this one might have been the tricky one, 2.43 times 10 to the 0. Remember, 10 to the 0 is only 1, and any number times 1 is itself. So you should have gotten 2.43. Ooh, let's try this one. This is how they might be asked of you on a test or even on the state test as a word problem. So let's read this together. It says the wavelength of an ultraviolet wave is 4.0 times 10 to the -3rd meters, and the wavelength of a radio wave is 1.0 times 10 to the -2nd meters. Which one has a longer wavelength, the ultraviolet wave or the radio wave? What I want you to do is go ahead and pause the video, give it a try, and then come back for the answer. Hopefully you pause the video. I'm really hoping. So let's check out our answer. If we look at the ultraviolet wave, and we're going to move that decimal 3 places to the left, because the exponent is a -3, I get 0.004 meters. That's my ultraviolet wave. If I look at my radio wave, it has an exponent of a -2, so I have to move my decimal 2 places to the left. So the radio wave is 0.01 meters. So which one's longer? Which one's a bigger number? Is 0.004 larger or is 0.01 larger? Hopefully, everybody got the radio wave is larger, because 0.01 or 1/100th is actually bigger than 4 thousandths. Here's your focus question. Go ahead and answer these 3 questions. Bring them to class with you tomorrow and we'll go over them. I hope you enjoyed the lesson today. Talk to you soon. See you tomorrow.